Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of an engineering object in which the front face, the right hand side view face and the top view face of the solid, they have been combined into a single 3D isometric projection view over here. So using the information available with us through this 3D isometric projection, we are required to draw the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections over here. So in order to obtain the orthographic projections of the object, we need to obtain the dimensions of the front view face, top view face and the right hand side view face over here. So as we look at the solid from the front side, we observe that the width of the solid happens to be 100 millimeter and the height of the solid happens to be equal to 75 millimeter. So the front view face of the solid will be having the dimensions 100 millimeter width and 75 millimeter height of the solid over here. Similarly, when we look at the solid from the top, again we observe that the width of the solid, it is equal to 100 millimeter, while the depth of the solid happens to be equal to 64 millimeter. So the top face of the solid is going to measure 100 millimeter by 64 millimeter. Similarly, when we look at the solid from the right hand side view, we observe that the depth of the solid happens to be equal to 64 millimeter, while the height of the solid, it is equal to 75 millimeter. So the right hand side view face of the solid, it is going to measure 64 millimeter by 75 millimeter. So with this information, now we are going to obtain the orthographic projections of this engineering object over here. So here we have drawn the XY reference line, the X1, Y1 reference line and a transfer line at an angle of 45 degree from this origin point, such that we should be able to convert the distances alongside the depth of the solid which are obtained into the top view projections into the right hand side view projection view over here. So here, since we are going to obtain the orthographic projections of the solid into the first angle projections, so the front view projections of the solid, they will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line and the right hand side view projections of the solid will be obtained on left hand side of the front view projections over here. Now as we observe the solid from the front side, now we observe that the width of the solid happens to be equal to 100 millimeter. So now we have drawn two vertical projector lines into the front view projections which are separated by distance is equal to width of the solid equal to 100 millimeter. And these two vertical projector lines, we have extended them into the top view projections because the width of the solid into the top view projections will also be equal to 100 millimeter. We also know that into the front view projections, the height of the solid, it happens to be equal to 75 millimeter. So again, a horizontal projection line we have drawn at a height of 75 millimeter above the XY reference line into the front view projections over here, and we have extended this horizontal projection line into the right hand side view projections as well, because into the right hand side view projections the height of the solid, it will be equal to 75 millimeter. Now as we look at the solid from the top, so once again we can check the width of the solid happens to be 100 millimeter, while the depth of the solid, it is equal to 64 millimeter. So into the top view projections, we have drawn two horizontal projector lines which are separated by the distance 64 millimeter, which is equal to depth of the solid over here. And these two horizontal projector lines, we have transferred them into the right hand side view projections, because into the right hand side view projections, once again we are going to obtain depth of the solid is equal to 64 millimeter and the height of the solid, it is equal to 75 millimeter over here. Now we have been able to obtain the front view face, the top view face and the right hand side view face corresponding to this engineering object over here. Now as we look at the solid from the front, we can divide the solid into three elements over here. The element number 1, it happens to be a horizontal wave which is having the dimensions 100 millimeter width, 22 millimeter, it is the height of the horizontal block, and 64 millimeter, it is the depth of the horizontal block. Whereas element number 2, it is a vertical wave which is perpendicular to the front face of the solid, and this vertical wave, it is having the dimensions width is equal to 15 millimeter, depth it is equal to 64 millimeter and height it is equal to 75 millimeter. Whereas there is another vertical wave which is lying over here, which we are going to refer to as element number 3, and this vertical wave which happens to lie centrally on top of the horizontal wave. This horizontal wave, it is parallel to the front face of the solid. So this is an inclined wave which is parallel to the front face of the solid. So this way we are going to obtain the orthographic projections of the solid while we have divided the solid into three elements over here. So corresponding to element number 1, which happens to be a horizontal wave, we know that the height of the horizontal wave, it happens to be equal to 22 millimeter. So therefore at a height of 22 millimeter from the ground, we have drawn a horizontal projector line into the front view projections which is going to depict the top surface of this horizontal wave which is available with us at the base of the solid. So we have extended this projector line into the right hand side view projections as well over here. Now we observe that this horizontal wave, it carries an angular hole at the center of the solid when we are going to look at the solid from the right hand side view over here, and the top surface of this angular cross section which is available at the base of the solid, it happens to lie 12 millimeter above the base of the solid over here. So corresponding to the top surface of this angular slot which is available at the base of the solid, now we have marked this distance 12 millimeter from the base of the solid, and we have drawn a horizontal projector line into the front view projections and extended this horizontal projector line into the right hand side view projection view over here. Next we have got this vertical wave. So into this vertical wave, that is element number 2. So we know that this vertical wave, it is lying onto the left hand side portion of the solid, and this vertical wave, it happens to be perpendicular to the front face of the solid over here. And we have observed that this vertical wave, it is having width is equal to 15 millimeter. So from the left face of the solid, we have marked a distance of 15 millimeter, and we have drawn a vertical projector line into the front view projections and extended this vertical projection line into the top view projection over here. So this way the width of the vertical wave which is corresponding to element number 2 has been obtained into the front view projections over here. Next we have got this element number 3. So we know that from the front face, we can check, this is the front face of the vertical wave having width is equal to 15 millimeter, which happens to lie on the left hand side portion of the solid over here. So from the front face of this vertical wave, here we have got element number 3, which happens to be inclined vertical wave, which is located centrally on top of this horizontal web over here. And this web, it is having the width equal to 70 millimeter measured from the front face of this particular vertical web, which is corresponding to element number 2 over here. So from the front face of the vertical web, which is element number 2, we have marked a distance of 70 millimeter towards the right hand side portion of the solid. Now after marking this distance of 70 millimeter, now we have marked a vertical projector line into the front view projections, and we have extended this vertical projector line into the view projections over here. So next we have got this position, that is the height of element number 3. So we know that element number 3, it is resting on top of the element number 1, which happens to be a horizontal web. So from the top surface of the horizontal web, which is element number 1, if we move in the upward direction by a distance of 40 millimeter, so the top surface of the element number 3 will be obtained over here. We have marked a distance of 40 millimeter height above the top surface of the horizontal web over here. So after marking this distance, that is 40 millimeter above the top surface of the horizontal web, we have obtained a horizontal projector line into the front view projections, which is going to depict the top portion of this element number 3 over here. And we have extended this projector line into the right hand side view projections as well. Now next we can join the bottom portion of the element number 3 with the top portion of the element number 3 into the front view projections over here. So the bottom portion of element number 3, it happened to lie on the top surface of element number 1, which is the horizontal wave, at a distance of 70 millimeter in front of the front face of element number 2 vertical web over here. It happens to be this point. Similarly, the top surface of element number 3, it happens to lie 40 millimeter above the top surface of the horizontal web alongside the front face of the vertical web over here. So at a distance of 62 millimeter from the ground, we have marked the top position point corresponding to element number 3 over here. So the true shape triangular projections corresponding to the element number 3, they have been obtained into the front view projections over here. Why these projections, they happen to be true shape projections? Because this element number 3, that is an inclined vertical web parallel to the front face of the solid, it is also parallel to the vertical plane. Now corresponding to element number 2, we observe that the total depth of the solid happens to be 64 millimeter, while there are 2 inclined surfaces which are available onto this vertical wave in such a way that first inclined surface is starting at a distance of 16 millimeter from the front face of the solid, and the second inclined surface again, it starts at a distance of 16 millimeter from the rear face of the solid over here. And another thing we need to observe over here, that the lower portion of this inclined surface, it happens to lie at a distance of 16 millimeter from the top face of the solid. So this is the top face of the solid. So at a distance of 16 millimeter from the top face, if we move down from the top surface towards the base of the solid, we are able to obtain the bottom portion corresponding to this inclined surface over here. So now corresponding to this 16 millimeter distance from the top surface of the solid, we have obtained the horizontal projector line into the front view projections, and this horizontal projector line, we have extended it into the right hand side view projections over here. So this way, this point corresponding to the inclined surface has been obtained into the front view projections over here. So now once we look at the solid from the front view orientation, now we can see we are going to obtain L-shaped rectangular projections corresponding to this face of the solid over here. Now we can see that this portion which happens to be an inclined surface, so corresponding to this inclined surface, we have been able to obtain apparent shape projections into the front view projection area over here. Whereas corresponding to this L-shaped surface over here, we are able to obtain true shape projections corresponding to this surface into the front view projections over here. Similarly, if we join this top point with this bottom point, now we can check corresponding to this element number 3, we have been able to obtain true shape triangular projections into the front view projection over here. Similarly, we can check here we had got an angular slot which was running parallel to the front face of the solid throughout the entire width of the solid over here. So corresponding to this angular slot, for which the top portion of the slot, it was lying at a height of 12 millimeter from the ground, we have been able to obtain a hidden line projection into the front view projections over here. So this way we have been able to obtain the front view projections corresponding to all the 3 elements of this solid. Now let us proceed to evaluate the top view projections of the solid over here. Now this element number 3 and this angular slot, so both of these entities, they are lying at the center of the solid corresponding to the depth of the solid over here. So since the total depth of the solid was equal to 64 millimeter, so we have marked the center of the solid alongside the length at a distance of 32 millimeter from the rear face of the solid. And we have obtained a center line into the top view projections over here. And this center line, we have extended it into the right hand side view projection area using this transfer line over here. Next, we have got the information regarding this angular slot which is lying at the base of this solid, that is into the element number 1, which is the horizontal web. Now we know that the top surface of this angular web, it is having dimension equal to 30 millimeter. So since this slot is located centrally alongside the depth of the solid into the element number 1, that is the horizontal wave, now from the center point we have marked a distance of 30 millimeter, that is with an offset of 15 millimeter. We have drawn 2 vertical projector lines into the side view projections, and now we have transferred these 2 vertical projector lines which are separated by a distance of 30 millimeter into the top view projections over here. So now we can check, this is the top portion of the slot which is available into the horizontal wave, but this slot, it is not visible to the observer over here. So now we are going to observe the hidden line projections corresponding to the top portion of this angular slot which is available onto the base of the horizontal web over here. Now another information we have got from these 2 top points. Now we can observe from the right hand side view projections over here. Now we can obtain the bottom portion of this angular slot once we are able to obtain these inclined projector lines over here corresponding to these 2 inclined surfaces, and these inclined surfaces, they happen to exist at an angle of inclination of 60 degree with respect to the base over here. That is from these 2 points. Now 2 inclined projector lines we need to draw over here corresponding to this face, corresponding to this face. And now we will see that this angle of inclination, it will be equal to 60 degree, and this angle of inclination, it will also equal to 60 degree, or as an alternate angle we will find that this angle of inclination will be 60 degree and this angle of inclination will be equal to 60 degree. So from these 2 points which are corresponding to the top surface of the angular slot, we are going to mark angles of 60 degree on either side. We'll be able to obtain the 2 edge view projection lines corresponding to inclined surface number 1 and inclined surface number 2 over here. And these 2 points corresponding to the slot at the base of the solid we have been able to obtain into the right hand side view projection view over here. And once we obtain these 2 points, once again 2 vertical projector lines, they will be obtained onto the transfer line, and then these 2 vertical projector lines, they have been transferred into the top view projection area over here. This way the bottom edges corresponding to this slot, corresponding to this angular slot, has been obtained into the top view projection area over here. And once again, this bottom edge, it will also not be visible from the top. So once again we are going to obtain the dotted or the hidden line projections into the top view projections over here corresponding to this angular slot. Now next we have got the element number 3 over here. So we can check this element number 3. It is having depth equal to 12 millimeter, and again it is located centrally on top of the web number 1, which is a horizontal web. And now from the center point we have taken an offset of 6 millimeter on the rear side and 6 millimeter on the front side, so that the depth of this web we have been able to obtain as 12 millimeter. So corresponding to element number 3 depth over here, now we have been able to obtain 2 horizontal projector lines. This is horizontal projector line number 1. This is horizontal projector line number 2. And these 2 horizontal projector lines we have been able to transfer into the right hand side view projection view using this transfer line available over here. So as we observe the solid from the top, so we observe that we are going to obtain rectangular projections corresponding to the boundary of this object into the top view projections over here. And now we can check corresponding to this element number 2. We know that the width of this element number 2 happens to be equal to 15 millimeter. So at a distance of 15 millimeter from the left hand side face, we are going to obtain the rectangular projections from the top view projections over here. We are going to observe that this inclined surface corresponding to element number 3, it is observed as an apparent shape projections into the top view projections over here. Why? Because this inclined surface having depth is equal to 12 millimeter, it happens to be inclined with respect to the horizontal plane. So we are able to obtain the apparent shape projections corresponding to the top surface of element number 3 into the top view projections over here. And again we have discussed corresponding to these 2 top surface edges which are running parallel to the front face of the solid throughout the width of the solid over here, we are going to obtain dotted line or hidden line projections into the top view projections over here. Similarly, corresponding to this angular slot which is cut into the base of this horizontal wave, we are going to obtain dotted projection lines into the top view projections over here. And another thing now we have to observe that corresponding to element number 2, so we have divided the top portion of the element number 2 into 3 portions. This is a flat portion having dimensions 32 millimeter, it is the depth over here. 16 millimeter is the depth corresponding to the inclined surface which is lying on the front side. 16 millimeter happens to be the depth corresponding to the inclined surface which is lying onto the rear side of the solid over here. So from the center point which we have already located, now what we have done, we have marked an offset of 16 millimeter on the either side, so that the distance between the extreme projector lines which we have obtained into the top view projections, this should be equal to 32 millimeter. So now we can check once again the distance corresponding to inclined surface on the front side, it is 16 millimeter. The depth corresponding to inclined surface on the rear side is 16. So the remaining intermediate distance corresponding to this flat surface will be 32 millimeter. So we have marked this distance into the front view projections, and now we can check. So this rectangular projection will be the top view apparent shape projections corresponding to this inclined surface which happens to lie on the rear side of the solid over here. Similarly, this rectangular projection, it happens to be the apparent shape top view projection corresponding to this inclined surface which happens to lie towards the front face of the solid. This is the front face of the solid, and these two projector lines we have transferred onto the right hand side view projection view using this transfer line over here. So this way we have been able to complete the top view projections corresponding to the solid. Now when we look at the solid from the right hand side view, now we can check. We will be able to observe this angular slot from the right hand side view. So the base, this portion will be available, and this angular slot will be visible to the observer. And from the right hand side view, this portion is visible, this portion is visible, then the three segments of element number 2 will be visible at the top. So now we can check. This is inclined portion on the front side of the solid over here which will be visible to the observer. Then there is a flat portion which will be visible to the observer. Then we are going to witness this inclined surface of the solid corresponding to element number 2 which is available at the rear side of the solid. And then there is the vertical surface of the solid corresponding to the rear surface of the solid over here. Next we have got the height of this horizontal web. So the height of this horizontal web happens to be equal to 22 millimeter from the ground. So corresponding to this distance of 22 millimeter from the ground, this top portion of the horizontal web corresponding to element number 1, it will be visible to the observer. And finally we have got this inclined surface corresponding to element number 3 which will be visible to the observer. So corresponding to the top point, which is this one, corresponding to the bottom point from the front view projections. So a rectangular projections we have been able to obtain into the right hand side view projections, and this projection happens to be apparent shape rectangular projections corresponding to this inclined surface of this web which is our element number 3 over here. So this way we have been able to obtain the orthographic front view projections, the orthographic top view projections, and orthographic top view projections, and the orthographic right hand side view projections corresponding to the solid for which the 3D isometric projections, they were available with us. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids into the coming lecture discussions. So thank you very much. Thanks a lot.